Hey guys, welcome back to 5.4. Another problem: to supplement his pension in the early years of his retirement, Hong plans to use $400,000 of his savings as an ordinary annuity that will make monthly payments to him for 20 years. His interest rate is 5.2%. How much extra will his savings pay him per month? So he's taking this money and he's feeding it out to himself while it earns interest. I'm going to refer to this as a sinking fund. So it's exactly like the last problem where you're looking for the payment though, which means you'll use the second half of the formula, which is the normal amortization formula. It's just backwards. So the idea of amortization is you make a lump sum purchase and slowly pay it off. Here, you have a lump sum investment that's slowly paying you off. So you're the equivalent of the bank who's loaning money to yourself. So keep that in mind. We'll look at 4 though for a more straightforward problem. Toyota is offering a 2.84% auto loan rate for cars. Jacob wants to buy a used car that costs $18,700. Find his monthly payment for the car. So this is amortization. So this is our payment equals A times R over N over 1 minus 1 plus R over N to the negative NT. We just put everything where it goes. 18,700 times R over N, so 0.0284 over 12, divided by parentheses 1 minus parentheses 1 plus that 0.0284 over 12, close parentheses to the negative 12 times, we'll say his payments, he's going to pay this car off over, it doesn't say it, but auto loans usually come in anywhere from 3 to 6 years, so we'll assume he's paying it off over 5 years. In the problem, anytime you get it, it should tell you how fast they're paying it off, but in this case it didn't, so we're just going to come up with a reasonable time to pay it off. So 18,700 times 0.0284 over 12 divided by 1 minus 1 plus 0.0284 over 12 to the negative 12 times 5 power. He will have to make payments of $334.69, which is not a bad monthly payment, all things considered. 2.84% is a decent rate. And the car is reasonably expensive, relatively speaking. Of course, this doesn't cover any extras, but that's how much he would pay per month. And you can check how much interest he would pay by multiplying his payments per month by the total number of payments, which is the same as this number, but positive, to see the difference in price, which we'll do more when we get to a house problem. So remaining balance is a special circumstance. It's a variant of our current value formula. The only difference is there's this x here in the numerator of the exponent, where x is the number of payments you've already made. So on October 10th, 2016, the average rate, so just keep that in mind. If they ask you how much you owe left, we'll do one on the test review that's like that. On October 10th, 2016, the average rate for a 30-year fixed mortgage was 3.37%. Assume the average person makes a down payment on a home that's 20%. How much would the average person have to pay on a $300,000 home? And how much do they still owe on the loan after 10 years? So that'll be that last question there will be our remaining balance. And how much do they end up paying for the home for the 30-year life of the loan? This is always a depressing question. So let's see. Okay. So we know T is 30. R is 3.37% or 0.0337. Okay, so question 1. If they're making a down payment, they're not borrowing for that. So let's talk about the down payment. Because that's going to be part of their total payment on the home. So it's 20% of 300,000, so 0.2 times 300,000, which is 60,000. So they pay $60,000 up front, which leaves the other $240,000 is going to be borrowed to pay off the rest. So that would be our A in the case of the equation. So if we're talking specifically on how much they pay per month, let's talk about the monthly payments. Our payment is going to equal A, 240,000, times R, 0.0337 over N, 12, divided by parentheses 1 minus 1 plus 0.0337 over 12. They're paying it off over 30 years, so negative 12 times 30, close parentheses. So let's see what this is. By the way, 30 years of payments is 360 payments, which is a little insane. So they make a monthly payment of $1,060.37, which you may think doesn't sound bad. So before we talk about how much they still owe after 10 years on the whole after 10 years, let's talk about how much they end up paying first. They made monthly payments of $1,060.37. They made this payment 12 times a year for 30 years. So 1,060.37 times 12 times 360, or 12 times 30. That's $381,733.20. But they also already paid $60,000 as a down payment. So they really paid $441,733.20 for their $300,000 home. That's almost $140,000 of interest. That's almost half the whole cost of the house paid as interest. Now, if we want to know how much they owe after 10 years on the loan, we use that equation from above, the balance. So that's our payment. It's $1,060.37 times 1 minus 1 plus 0.0337 over 12. It says to the x minus nt. So we know the negative nt is this thing. X is the number of payments they've already made. So after 10 years, you've made 120 payments, 12 a year. So really this is now to the negative 240, because it's 120 minus 360, all divided by the R over N, so 0.0337 over 12. So how much do they still owe after 10 years? Is this thing. So we've got 1,060.37 times 1 minus 1 plus 0.0337 over 12 to the negative 240 divided by 0.0337 over 12. They still owe $184,958.42. So in the first 10 years of a $240,000 loan, they still owe $185,000, which is surprising. You think a third of the way through, they should be a third of the way through paying it off. But the reality of the fact is, at the beginning of the loan, because you owe so much, there's more interest. So at the beginning, you're paying off more interest, which means they've only paid off, despite the fact that they've made over $120,000 in payments up to here, they've only actually paid $55,000 off the principal of their house. We will finish this section in the next video.